Okay, here we have a graph of a power function, or at least I attempted to draw it as a power function. I didn't construct it all that carefully. It'll serve for illustration whether it's constructed correctly or not. And an exponential function with a negative value of its doubling, with a negative doubling displacement, okay? So x sub d, and I usually use delta x sub d to represent a doubling displacement. And you should be familiar with how that would be constructed. Again, whether I did it well or not doesn't matter for the purposes of this illustration, although if you're trying to do this with a specific power function and a specific doubling displacement, then you want to make sure you have the graphs constructed carefully. Okay, so what we're going to do here is we're going to take each value of x here and determine the value of u, and then we're going to take that value of u, which we get here, we're going to take that value down to this u axis and construct the value of f. And then we're going to have a graph that shows the value of f versus the original value of x. Okay, and this is a chain of values, and what then we have is a chain of functions. We'll start with, let's say, this x value. Okay, so starting here at this value of x, we can get the value of u. How do we do that? Well, we just project up to this line, up to the curve, and across here, and here's our value of u on the axis. Now that value can be represented by this distance from the origin up to this point, which means that it can be represented by a line segment from this point on the x-axis up to the graph. Okay, well, then there's our value of u that corresponds to this value of x. And that can be constructed very easily. You can do this with compass and straight edge. And you can certainly take your compass. I could actually probably do that with this one. The compass doesn't spread that all that far, but I think it'll get this, okay? So we can do that. And then we can bring the compass down here. Now the u-axis here is horizontal. And the compass point brings me over to here. So if I come over this far, this segment has the same length as this segment. And now, and I'll indicate that, okay? I'm going to do this a little differently than I did in another quicker video. And I'm not actually sure that one's going to go quicker. We'll see how quick this goes. But I'm going to put a tick mark through here and a tick mark through here to indicate that this segment has the same length as this segment. Now I'm going to find the value of f that goes with this value of u. How do I do that? Well, I project out to the graph and over here, and right there's my value of f, and it's represented by a line segment of this length. I'm going to put a double tick mark through this. Now before, I didn't put a tick mark through this one. I put a single tick through this one. Now the compass isn't going to spread that far, at least not without destroying it. But I'll use my fingers to indicate a compass. Okay, so we pretend this is a compass. Right there is our value of f, represented by the length of this line segment. Now our value of x, you know, if you use another compass, is represented by the length of this segment. Now, if I want to construct f versus x, I take this value of x and put it over here. So I'm going to do that. So here's my value of x, the same as the value of x that we started with here. And then I can take my value of f. I don't need the value of u. I already used that to find the value of f. Take my value of u, and I put it over here. I put a line segment of that length here. And I've got a point on my graph of f versus x. Okay, well, I'll do the same thing. do the same thing with this point. Okay, so with this point, my value of x, you should see, is going to be equal to the length of this little segment here. So I'm going to bring that little segment down here and make a segment of that length. Put a little tick mark through it to indicate I've got one in this one. If you've got good resolution, you should be able to see it. And now I find my corresponding value of f, which will be this. Okay, well, now my x value is here, so I bring my compass over here and I mark my x value here. And my value of f is this, so I have to do this. I have to make a segment this long. Put a couple of tick marks through it, and there's my value of f at that value of x. Okay? So let's go on a little further and let's find a good color here. Let's work it for this value of x. Okay, well, same procedure. I project up and over, then I'm going to see that my value of u is now this. Okay, somewhat bigger than either of the other two. And I'll put up just a single tick through that line. Now, set my compass at this distance and make a mark here. Here's my segment that represents the value of u that corresponds to this value of x, and put a tick mark through it. It still looks like I got a double tick mark through this one. I don't know if I'll be able to get rid of that. In any case, so here's my value of u. The corresponding value of f is here. Put a double tick through the value of f, and I take that, and I can actually do that with my compass now. But let's first get the x value over here. So, I need to use a bigger compass. Okay, it's going to be about like this. Okay, not a very good compass, is it? Okay. So here's my x value, same as this x value. And using my compass, here's my value of u, my value of f. Okay, so I put that mark here, and I get a point like right here. Okay, now there's another value of f that I can get, and that's the value that corresponds to x value 0. Okay, well, if the x value is 0, what's the value of u? Well, I'm at the origin, and this graph, being a graph of a power function, goes through the origin, so my value of u is clearly 0, which means I don't have any segment. It means that my value of u is 0, so I come down here to value 0. That's going to give me a point here, and it's now going to give me a value of f that corresponds to the length of this segment, so I put that up here. Right, draw that segment, put that point here. And I forgot to draw my segment for the value of f over here. Just to be consistent, I want to do that. Okay, now I've got, 4 points, and I want a graph to go through these 4 points. Well, if I do that, I get a graph that looks something like this. Okay, well, that's a pretty well constructed graph, and it has about the shape I was hoping it would have. Now, do you recognize anything about this shape? Well, if I project back in this direction, I see that this is half of a bell-shaped curve. Plausibly. And I'll say plausibly half of a normal, and in parentheses I'll say bell-shaped curve. And then I'll make a statement. If u is a power 2 function and f of x and f is an exponential function of u with negative doubling displacement, which I indicate by delta x sub d, then if scaled properly, f versus x is a standard normal curve. With area 1. That means the total area between the curve and the x-axis is 1. Okay? And by scaled properly, I mean you scale it so that the area is 1. If you do that, you have a standard or a curve that can at least be labeled as a standard normal curve. And there's more to the details of the scaling, and I'm not going to go into those details. It's kind of interesting, and I might go into those details later. Not too difficult. You have to choose your scale along the x-axis properly, and again, I'm not going to address those details in this video. This is how you can construct the graph of a composite function.